Ever wondered what's the smallest unit of life that forms the protective barrier in our bodies? It's called the epithelium. This microscopic marvel, the epithelium, is an unsung hero that works tirelessly to keep us healthy. Imagine it as a dynamic shield, constantly regenerating and adapting to protect our bodies from the external world. The epithelium's characteristics are as intriguing as its role. It's a thin layer of tightly packed cells forming a continuous sheet, and it doesn't have any blood vessels. Surprising, isn't it? Despite being avascular, it's incredibly resilient and plays a crucial role in our body. It's the first line of defense against pathogens, and it also aids in absorption, secretion, and sensation. The epithelium isn't just one uniform layer though. There are different types, each with its unique structure and function, perfectly adapted to its location within the body. Now that we know what epithelium is, let's delve deeper into its types and functions. Epithelium isn't just a one-trick cell, it has various types, each with their unique roles. Now, let's dive in and explore these fascinating cells. Firstly, we have the simple epithelium. As the name suggests, it's a single layer of cells. It primarily serves as a covering and lining for body organs, and its thinness allows for efficient material exchange. Next, we have the stratified epithelium. Unlike the simple epithelium, it has multiple layers of cells. This makes it perfect for areas of the body that need protection against wear and tear, like the skin. Now let's look at the squamous epithelium. It's flat and scale-like, hence the name squamous, which means scale. It's found in areas of the body where rapid diffusion is necessary, like the alveoli in the lungs. Moving on, we have the cuboidal epithelium. These cells are cube-shaped and are great at secretion and absorption. They're commonly found in the kidney tubules and the glands. Next up, the columnar epithelium. These cells are tall and column-like. They're perfect for secretion and absorption too, and you can find them lining the stomach and intestines. Last but not least, the transitional epithelium. It's a bit of a shapeshifter. It can stretch and recoil, making it ideal for organs that need to expand and contract like the bladder. Each type of epithelium has its unique characteristics and functions, which contribute significantly to the overall functioning of our bodies. They protect us, help us absorb nutrients, facilitate gaseous exchange, and so much more. Remember, the epithelium isn't just a bunch of cells. It's a highly specialized and organized system that plays a crucial role in maintaining our health and well-being. So, those are the types of epithelium. But where exactly do we find them in our bodies? Scene script. Epithelium cells are like the unsung heroes found throughout our bodies. Imagine them as the versatile actors of our biological theater, playing different roles in different locations. The simple squamous epithelium, for instance, lines the blood vessels and the air sacs of lungs, facilitating the exchange of gases. Meanwhile, the cuboidal epithelium, resembling tiny cubes, is found in your kidney tubules and glands. These cells are responsible for absorption and secretion, crucial in maintaining body balance. Now, let's move on to the columnar epithelium, the skyscrapers of our cellular city. You'll find them lining the gut, playing a key role in the absorption of nutrients and production of mucus. And let's not forget the stratified squamous epithelium, the body's protective shield. You'll find them in areas exposed to wear and tear, like the skin and the lining of the mouth. Now that we know where to find them, let's talk about how they are supported. Enter the basal lamina. Ever heard of the term basal lamina? It's the support system of the epithelium. Let's dive into the microscopic world of epithelial support systems. The basal lamina, often referred to as the basement membrane, is a thin, fibrous structure that acts as the foundation of the epithelium. It's kind of like the bedrock upon which the epithelial cells are built. This structure is composed of two layers, the lamina lucida and the lamina densa. The lamina lucida is the clear layer closest to the epithelial cells, while the lamina densa, as you might guess, is the denser layer beneath it. The basal lamina is more than just a static support structure. It also plays a dynamic role in the function and survival of epithelial cells. It serves as a filter, allowing only certain molecules to pass through. It aids in the healing of wounds, guiding the movement of cells to damaged areas. Furthermore, it provides signals for cell differentiation, helping cells understand what they need to become. Now let's shift our focus to cell junctions. These are specialized structures that connect adjacent cells, allowing them to communicate and function as a unit. There are three main types of cell junctions: tight junctions, adherence junctions, and gap junctions. Tight junctions are like the bouncers of the cell world. They form a seal around the cells, preventing substances from leaking between them. Adherence junctions, on the other hand, are like the glue that holds cells together, providing the structural integrity needed for tissue formation. And finally, we have gap junctions, the communicators of the cell world. These junctions allow for direct communication between cells, enabling them to rapidly share information through electrical and chemical signals. From providing support to ensuring tight-knit connections, the basal, lamina, and cell junctions are crucial. But what about the specialization of the cell surface? Epithelium cells aren't just about protection, they have other specialized roles too. You see, the surface of epithelial cells is not uniform. It has evolved to perform specific functions depending on the location and needs of the tissue. Let's delve into this fascinating aspect. First up, we have the microvilli. These are tiny, finger-like projections that increase the surface area of the cell. Why is this important, you may ask? Well, in areas where absorption is crucial, such as the small intestine, these microvilli come into play, allowing for a greater area to absorb nutrients. It's like having more hands to catch a ball, more surface area, more absorption. Next, let's talk about cilia. These are longer, whip-like structures, which move in a coordinated fashion to transport materials. Picture this. You're in a crowded room and you want to pass a note across. You can't move, but the people around you can. So you pass the note from person to person till it reaches its destination. That's how cilia work. In the respiratory tract, for instance, cilia help to move mucus and trapped dust particles upwards and out of the lungs. Now, let's move on to stereocilia. These are long, non-motile microvilli found in the inner ear. They're involved in the detection of sound and movement. In the ear, these stereocilia bend in response to sound vibrations, triggering electrical signals that the brain interprets as sound. It's thanks to these tiny structures that we can enjoy the symphony of life. These are just a few examples of the specialization of the epithelial cell surface. Each structure has a unique role tailored to the needs of the tissue it resides in. From absorption to protection to sensory perception, these specializations enable the epithelial tissue to perform a wide range of functions far beyond what we may initially perceive. These specializations make the epithelium a versatile and vital tissue. Now let's discuss a fascinating phenomenon, metaplasia. Imagine if a cell could change its type depending on the body's needs. That's metaplasia for you. In the grand scheme of life, change is the only constant, and our body's cells are no exception to this rule. Metaplasia, a fascinating phenomenon, is all about transformation. It's the process where a mature cell type morphs into a different mature cell type, and it's a testament to the adaptability and resilience of our epithelial cells. But what causes this metamorphosis? Let's take a step back and think about it. Our body is a finely tuned machine, constantly adapting to the environment, both internal and external. When the body is subjected to chronic irritation or inflammation, it doesn't just sit back and take it. Instead, it fights back, and one way it does this is through metaplasia. The cells in the affected area change their type to better withstand the new conditions, like a knight trading his sword for a shield when the battle strategy changes. For instance, consider the bronchial epithelium in smokers. The constant irritation from the smoke induces a change from ciliated columnar cells to squamous cells, a tougher cell type better equipped to handle the smoke's onslaught. This transformation is an example of metaplasia. But like any superhero story, there's a darker side. While metaplasia is a protective mechanism, it's not without its risks. The cells undergoing metaplasia can sometimes lose their way, leading to dysplasia, a precancerous condition. This is why it's crucial to monitor and manage conditions that cause chronic irritation or inflammation to prevent metaplasia from taking a wrong turn. In essence, metaplasia is a remarkable demonstration of the body's adaptability. It shows how our cells can learn new tricks to protect us, changing their very nature to suit the situation. It's a reminder of the resilience of life and the incredible complexity of our bodies. Metaplasia is a testament to the adaptability and resilience of epithelium. So, we've journeyed through the microscopic world of epithelium. We've discovered the diverse types of epithelial cells, from the simple to the complex, each with their specialized roles. We've explored their distribution, how they form the linings of our body's cavities and surfaces, acting as our first line of defense. We've delved into their functions, understanding how they protect, absorb, secrete, and sense, creating a dynamic interface between our body and the environment. We've examined the intricate structures of basal, lamina, and cell junctions, the unsung heroes that hold these cells together, providing support and communication. We've marveled at the cell surface specializations, those tiny adaptations that make each cell perfectly suited to its role. And finally, we've unpacked the concept of metaplasia, the extraordinary ability of these cells to transform in response to their environment. That's the fascinating world of epithelium for you. Remember, it's more than just a protective barrier. Subscribe for more because you won't find me later.